Okay, this is networks page 5, and it's just continuing on with TCP. And I just want to show you what a TCP header looks like. So I'm going to box this in. I want a little room on the left for some annotation, and we need 5 lines. I'm actually going to add one more line afterwards. Some of these lines are split in 2. Each line represents 32 bits. So I'm just going to, in each of these, I'll indicate how big it is. So this is the number of bits that field is. And so the first field is the source port. And the second field is the destination port number, also 16 bits. The next row is the sequence number. So when a TCP connection is established, the client generates a random sequence number for security reasons, and it increments it with each segment that it sends, and the server does likewise. It generates a random sequence number and it increments that with every segment that it sends. And acknowledgement numbers are used to acknowledge previous segments that have been received, and the acknowledgement number actually indicates where in the byte stream it has received up to. Okay, now the next line is divided, so I'm actually going to fill in the right hand part first. This is the receiver window, and this indicates that when the other end is sending it segments, how much room it has left. So if it's getting full up, like the sender is overwhelming it, it will decrease the receiver window size, and the sender should throttle or reduce the rate at which it's sending segments so that it can catch up. On the left we have some flags, but first we have the header length field. And this is a 4-bit value. Then we have some unused bits. Then we have a number of flags. And there are 8 flags, so 4 plus 8 is 12, so that leaves us 4 bits for the unused portion. So it's unused in current TCP protocols, could be used in the future. And flags are used for things like signaling whether there's a meaningful acknowledgement number in the segment, for indicating that it's closing a connection, stuff like that. And the next line is divided into 2 parts. Oops. So we've got the checksum and something called the urgent pointer. And so the checksum is used to check the integrity of the data that's coming after the header. The urgent pointer was envisioned as a way of saying to the other end of the TCP connection that the data up to whatever byte is indicated there is very important and it needs to be delivered to the application immediately. In practice, it's not used these days. And then we have some optional it's just called options. And it can be used, for example, to negotiate the maximum segment size when the connection is being established. And so altogether, this can be from 20 bytes to 60 bytes. So if you go back to page 2 of the notes, I think it was, I corrected myself by doing a text overlay and saying it was 20 to 64 bytes. Well, that correction was wrong. It's actually 20 to 60 bytes, so I should have left that out. Okay, so that's the TCP header, and then following that, you'll have the data portion of the TCP segment.